A student takes an 8-question multiple choice quiz where each question has 4 choices. Because the student did not have time to study, she has to randomly guess at each answer. Number 1. What is the probability that she will get a 75% or better on the quiz? Well, before we can answer that question, we need to recognize that this situation is modeled precisely by a binomial experiment, where the number of trials is 8 because the student is going to make 8 guesses. For each guess, she is either right or wrong, so there are 2 outcomes, and the probability of success, the probability of getting it right, doesn't change because each question has 5 choices. Her probability of success is exactly 1 out of 4, or 1/4, where here we're talking about success means she gets it right. Means she guesses correctly. She guesses correctly. Okay, now that we have identified the problem, we can get the answer. Probability she will get a 75% or better on the quiz. Well, 75% means 3/4 or more. It just turns out that 3/4 of 8 is 24 over 4, or 6. So this means she needs to get a 6 or better. So we're being asked for the probability that x is greater than or equal to 6, which is exactly the same as the probability of getting any number right from 0 through 8 minus the probability of getting less than 6, that is, less than or equal to 5. So, on GeoGebra, that looks like this. 1 minus binomial dist. Number of trials, 8. Probability of success, 0.25. The number of interest is 5. And we do want a cumulative probability. So, over to GeoGebra, we'll ask for the answer. 1 minus binomial dist. 8 trials, 0.25 probability of success, variable value 5, and true. Oh, that's an exact answer. How about an approximate answer? There we go. 0.0042. Not very likely. 0.0042. 0.0042. So about a 0.42% chance of actually getting a 75% or better. Not too likely. Number 2, what is her expected score on the quiz? Well, the expected score is the expected value. So on average, we would expect people doing this to get according to our formula for the expected value, n times p, we would expect 8 times 1/4, or 2. 2 out of 8 is what we would expect to happen on average.